Okay, so first of all, I want to thank you, the speakers, for being with us today, and my colleague, Professor Ventura, of course, for the organization of the webinars. I just want to say a few words about an exhibition which is now on display at the Ben Gurion University, because this is a special project of our Ministry of Foreign Affairs, and it shows the outstanding work of a photographer, Fabiano Ventura, specialized in environmental topics and in mountain and landscape photography. The exhibition is promoted to the network of embassies, consulates, and Italian cultural institutes in the world, and it's heading in its objectives and principles to the United Nations Climate Change Conference in 2021, co-chaired by the UK and Italy at the end of 2021 in Glasgow. And the photos give us glimpses of the breathtaking landscapes that make Italy a unique country, but not only, because comparing contemporary and historical images, we can highlight the evolution of the glacial masses and reveal the tragic impact and consequence of climate change. That's why the exhibition is really important, because it shows not only this great Italian tradition linked to mountain culture and mountaineering, but it remarks the environmental value and the importance, above all, of environmental awareness, because this is the only way to preserve and respect not only such a wonderful country and anyway a unique ecosystem, but also human species and human civilization. In the occasion of this exhibition, Italian Roots, we decided to organize the two webinars. This is the second one, and webinars focused on the relationship among man, mountain, and dry land. And I want to leave now the floor to the chairman of the webinar, Professor Lazarovic, and I want to thank Professor Rakhmilevich, Professor Fait, and Professor Mattivi for their speech. Thank you very much.
Well, thank you very much for the introduction. Today, in the next 1.5 hours, we will explore 3 different projects from 3 excellent researchers that will talk about challenges that we have in our new situation with climate change. And we will see similarities between the 2 nations, Israel and Italy. I will be the convener for this session. My name is Naftali Lazarovic. I'm from Ben Gurion University of the Negev. So the world population is increasing, and there's no doubt about it. Yes, when I was born in 1972, the world population was about 4 billion people. Currently, it's growing and growing, and in 2022, it's about 7.5 billion people, and the prediction from 2050 that we will be around 9 billion. It means that we need to feed all those people, and we need a lot of food. And to create this food, we need a successful agriculture. It's not only food that we need, not only calories, we need to have a very healthy food and also nutritious food. In order to produce food, we need land. The land area was increasing for many years because we took forest and we changed the forest to farmland. But then in the recent years, in the last about 30 years, the land is decreasing, the land that is available for agriculture, because of various processes like sodification, salinization, and degradation of the soil. And those processes are what they are making that there is less soil that available for agriculture. And the current estimation that the average per capita that we have today 0.2 hectare. It's not a lot. And with this 0.2 hectare, we need to produce enough food per capita. In some countries, we have 0.4 like the industrial countries, but in some countries, the more developed countries, we have less than this, and we need to export food from one place to another. Regarding water, 70% of the water in the world is used for agriculture. In South Asia, in the Middle East, and Sub-Saharan Africa, this number is even higher. Between 80 to 90% of the water is going to agriculture. In Europe, for instance, the number is much lower, is only 35%. The rest of the water is going for domestic use and industry. And we will have a lot of pressure from the domestic and the industry. But in the end, we need water because we need to grow plants and they need water. And with climate change, probably they will need more water. And the water that is available for agriculture is more saline. And the rain in some places is going to change the rain pattern. What can we do? We must have more crop. We know it already. We need to feed the world, and we need to do it with less water, with less fertilizer, and with less land. We need to do it sustainably. We need to think about soil health, about the conditions in the soil. We want that the soil that we are using now and all the agrochemicals that we are using in agricultural production will not deteriorate the soil. We need to keep the emission low. We always, when we do agriculture, we have some emission, greenhouse gas emission, nitrate emission to the groundwater, and we need to minimize those, maybe even to put them as zero. This is the challenge. We must have multidisciplinary research approach, and today we will see several researchers that are talking multidisciplinary, and this is very important. Those are big questions to tackle: how to produce food, healthy food, in 2020 and even in 2050. We need to think about it and to work with many disciplines. And most importantly, I think that we need to collaborate with the industry, collaborate between us, collaborate with the farmer associations, and in the end, together we can make it. Professor Shimon Rachmilevich from Ben-Gurion University of the Negev will speak to us today about plants and carbon dioxide, past, present, and future. There's no doubt that the concentration in the air is increasing of carbon dioxide. When I started to study, it was about 340, 350, and today we are talking already about 400, 410 ppm. This is challenging, interesting, and many feedback can come from this concentration. Shimon will talk about it. After Shimon, we will have Fulvio Mattivi from the University of Taranto. He will talk about the cold climate that they have in Italy and how it can be good for growing wine, how the terroir in the mountain bubbles and what will happen to the white wines, those delicious white wines that we like to drink. And in the end, we will have Aaron Veit from Ben-Gurion University of the Negev. He will talk about the viticulture, the heroic viticulture that we make here in the Negev desert, with all the stresses that we have, namely high temperature, low relative humidity, high radiation, very big evaporative demand, with all those challenges that maybe in other places, other locations such as Italy or other places in Europe in the world, we will have in the future. We are already producing very interesting wine with our interesting terroir. Here we are in the center of the Negev, in Mitzpe Ramon, near Mitzpe Ramon, when the temperature today is about 8 degrees, and in Taranto, it's 7 degrees. It's pretty similar today. In the nighttime today, in Mitzpe Ramon, we will have freezing conditions between 0 to 1 degrees, even hotter than north of Italy. So with these similarities, I want to pass it to Shimon, and please upload your presentation. If you have any question in the chat, those that are here from the chat, please ask, and I will deliver this question later on to the speakers.
Thank you very much, Naftali, and thank you all for coming and for inviting me for this talk. I will talk today, I'll give a short review on what I see as important when I think about CO2 in plants, past, present, and future. So feel free to ask questions, and yeah, so I'll continue. Okay, so if we think about CO2 in the atmosphere, so we know that since the evolution of our atmosphere, that was, we are talking about close to 5 billion years ago, CO2 decreased very significantly. If we're looking only at the last hundreds of millions of years, we see this two large decreases, and this decrease is mainly due to the evolution of plants, land plants, and photosynthesis that caused this big decrease in CO2. And we are now here, much lower. The CO2 concentrations are much lower than the beginning of in the Earth, when it was much higher than here. But if we, and this is, we're talking about hundreds of millions of years and even billions of years ago. If we're talking about hundreds and thousands of years ago, we see this very stable ups and downs in CO2 that were for over 400,000 years, all until the last 100 years, where we started seeing, since the Industrial Revolution, this big increase in CO2, which can be seen from also from the Mauna Loa observations, where the Mauna Loa record shows a 30% increase in the mean annual concentration of CO2 since they started measuring. They started measuring in 1959. It was almost 316 parts per million, and now we are closer to 420 parts per million. So we have a 30% increase in a relatively very short time period. And if we look at it closer, we see this increase this is from the Mauna Loa from 1959 to our time now. If we look closer at this figure, we could see these ups and downs. And here we could see it even closer. So you see these ups and downs in the red. This is very typical. This specific up and down is measured in the northern hemisphere, since the Mauna Loa is in Hawaii, in the northern hemisphere, exactly like Italy and Israel. And what we see here is what is actually the up and down. The up and down is the effect of plants on our atmosphere. So up, down, the lower values every time signifies the time of the spring and summer, where light is not a limiting factor, and therefore there is lots of photosynthesis of plants and in the ocean that cause a significant decrease of CO2 in the atmosphere. Whereas in the winter, light is a limiting factor, less photosynthesis, therefore more respiration and less photosynthesis, and then we have ups and downs. So from this figure, it was very clear that our plants on our Earth affect the atmosphere. So if we're talking about the increase in the CO2, so a major cause of this increase is anthropogenic. What do I mean anthropogenic? From industry and from destroying of forests. But where does this CO2 go? So we know that over 50% of this CO2, the anthropogenic, is actually going to plants and to the oceans, causing what we call the fertilization effect. So our industry is fertilizing plants. It's increasing their photosynthesis just because we are polluting the atmosphere. So we have a substantial increase in the global photosynthesis since the pre-industrial times. If we can look here at this figure, we see this increase since the 1900s in photosynthesis. And you can see here on the y-axis, the global photosynthesis, the increase. And you could see that through the years, this is a very big increase, which the major part is the dark green, which is carbon dioxide fertilization, which is the source of it is mainly anthropogenic. So we see that plants, like I showed before, affect the atmosphere, but also the atmosphere is affecting plants. So it's a crosstalk situation between plants and CO2, where more CO2 is still a limiting factor for plants. On Earth, is still in our 420 ppm, or what is the number exactly, I'm not sure. So if we look, what is the effect of plants, what are the responses of plants to elevated CO2? So we know that doubling CO2 causes on the short term, a more or less 30% increase in photosynthesis here on the left side, and the upper left side. So this increase, this is from a paper that was published just this month, and we can see here this 30% increase in photosynthesis. And this increase is followed by less transpiration and less stomatal conductance, which causes an increase in water use efficiency. So under elevated CO2, plants are more water use efficient because they assimilate more carbon and they lose less water to the atmosphere. So there are different reasons why this lower transpiration, and part of the reasons is also that under elevated CO2, here you can see the xylem vessels, the vessels that transport water, get smaller. This is the effect of petioles. You could see here, this is from our paper from this month. This is the effect on petioles, which get smaller under elevated CO2. When petioles get smaller, water is transported much slower. So the slow transport and then slow loss of water. And you can see here that if we look at the conductivity of the plants, the petioles of the leaves is significantly, it's like 4 times less the hydraulic conductivity of petioles under elevated CO2. If this was in the petioles, and then we look in the roots, so in the roots we see, here let's look at the figure down here. Again, we have the same thing, a significant decrease in the average xylem of the roots, but this here is dependent on the nitrogen form. So only when the nitrogen form is nitrate, we see this decrease. When the nitrogen form is ammonium, we don't see this decrease. And this is, 1 minute, also affecting the hydraulic conductivity. Again, less than half the conductivity and the elevated CO2 in the roots. So plants adjust themselves when they have high CO2 to have very small vessels, which actually are safer under drought, but they cause very slow movement of water, which also is causing water efficient plants under elevated CO2. So if we talk about plants' responses to elevated CO2, we must talk about rubisco. Rubisco is the most abundant protein on Earth. Ribulose bisphosphate carboxylase oxygenase, that's the name. The main role of rubisco is assimilating CO2 in the left circle here in the photosynthesis. But the same enzyme that is assimilating CO2 can also assimilate oxygen to produce what we call the photorespiration. And the two processes come at the expense of one of the other. So if we have more CO2 on Earth, we'll have less photorespiration. And if we'll have less oxygen, we can have more photosynthesis, and vice versa. So this is the two processes: photosynthesis, more CO2, more photosynthesis; less CO2, more photorespiration. So what are the plant responses to elevated CO2? So in the short term, like I said, doubling CO2 increases photosynthesis rates by about 30%, and also increases the water use efficiency. But in the long term, what is very, very interesting, that this stimulation, the 30% increase, is many times declined to 12 or 13% on average. And this is a phenomena we call CO2 acclimation. This phenomena is more pronounced in areas, ecosystems where nitrate is the predominant nitrogen form, like wheat fields and grasslands, and less and a factor when you have ammonium as a predominant nitrogen form in more what we call basic. This is acidic, the nitrate, and this is alkaline soils. So like coniferous forests. Under elevated CO2, I showed also that photorespiration decreases. And another thing we see that under elevated CO2, doubling CO2 produces a significant decline in nitrogen in the plants. So we had an hypothesis that CO2, because when it's high, can inhibit shoot nitrate assimilation, because we see this decline in the nitrogen content in plants under elevated CO2. So how do plants take nitrogen? So the shoot nitrogen assimilation is a very, very energy demanding process. Lots of energy is invested. The process with the most energy invested in plants is nitrogen assimilation. You know that when you go at the airport and they are testing you actually for all kinds of residual of nitrogen. Because if you go the opposite way, it will create an explosion because of all this energy that is invested into this nitrogen assimilation. So we looked at, we took Arabidopsis thaliana, we took the wild type Colombia, and we took a nitrogen overexpressor, nitrogen reductase. This is the enzyme that is responsible for the reduction of nitrate to nitrite, and a nitrogen reductase deficient mutant that doesn't have nitrate reductase activity. And we show here that when we look at the overexpressor, it has more nitrate reductase activity. And when we look at the wild type, the activity reduces with time, meaning that old plants have very, very low nitrate reductase activity. And in our mutant, we had no nitrate reductase activity, no and then we used what we call AQ, assimilatory quotient, which is the ratio between CO2 consumption and O2 evolution. When plants photosynthesize, they consume CO2 and they evolve O2. And the ratio is not exactly 1, not always exactly 1, and we call it AQ. And it is considered a non-destructive measure for nitrate assimilation. We know that because transfer of electrons to nitrate and nitrite increases O2 evolution, and plants that are photoassimilating nitrate, they exhibit very low AQ. And then we use one more complex term we call delta AQ, which is the difference in AQ between plants that are fed nitrate to ammonia. And this is proportional. We will show here that the delta AQ is proportional directly to nitrate photoassimilation. So here we can see in young leaves which have nitrate reductase activity under CO2, which is 360, which is then, which we call atmospheric, now it's 414. We have significant delta AQ, but when we increase the CO2 to 700, we see a significant decrease in the delta AQ, showing a significant decrease in nitrate reductase activity in nitrate assimilation. In the double mutant or in the old leaves, we didn't see any effect because we didn't have nitrate assimilation. This is confirming what we said. And in the overexpressor, again, under elevated CO2, a significant decrease in nitrate assimilation. And what is interesting is also when we here the yellow lines, we give them atmospheric CO2 but very low O2, 2%. So this causes the photorespiration to be negligible. And when photorespiration is negligible, nitrate assimilation decreases very, very much, almost also to zero. So what are the conclusions for now? I showed that delta IQ is significant only in shoots that assimilate nitrate, and that elevated CO2 and low O2 are conditions that inhibit photorespiration. And this, the inhibition of photorespiration, inhibit also nitrate assimilation. So the conclusions are delta AQ, I validated it as a measure for nitrate assimilation. Elevated CO2, when I'll put here E, I'll make it out from that, this is elevated CO2, or decreased O2 inhibit shoot nitrate assimilation, and nitrate assimilation depends on photorespiration. And then we continue. You know that in C4 plants, photorespiration is negligible. So there's nothing to decrease when you change the atmosphere. And in the genus Flavaria, is a very interesting genus because it has 19 species, and they show evidence of evolution of photosynthesis that represent transition from C3 to C4. So we looked at C3 plants, which is Flavaria pringli, at 2 intermediates of Flavaria, and 1 Flavaria bidentate, which is a C4 plant. And we again, this is the 4 plants, and we looked again at this delta AQ, and what we saw here, the x-axis is CO2 increasing in the atmosphere. So elevated CO2 did not inhibit the red shoot nitrate assimilation in C4 plants. We didn't see any inhibition, and the intermediates behaved either like C3 plants or in an intermediate way. So now let's go to large-scale studies, and we're talking about what is called FACE studies, free air carbon dioxide enrichment. So just a year and a half ago, they went out and had a review summarizing 30 years of FACE studies. And they talk about 14 different sites in 5 continents, and they had over 250 observations. So there's a lot to learn from these observations. And these observations are not only elevated CO2, they are also combined with drought, temperature, and nitrogen fertilization stresses. So if you look at 186 independent studies of 18 different C3 crops, we can see that in here, all these crops here, we can see they showed an average of 18% increase in yield under non-stress conditions. So elevated CO2 causes an increase in the yield, except for C4 plants. C4 plants here did not show increase, except the C4 plants had an increase only under drought. Here, this is what is called C4WD. This is with drought. So under drought, C4 crops were more productive under elevated CO2, only under drought. We know that nitrogen deficiency and warming reduced this increase. So the increase was 18% under no stress, but under stress conditions, we had less increase. What you see here is the black circles is the maximum, the white circles is the minimum, but this is an average of 186 different studies. So clearly, elevated CO2 is increasing yield in C3 plants, less in C4 plants, and this effect is diminished under stress. But so it's not all good. So elevated CO2 is increasing yield, but what we can see, there is more yield, but reduced levels of nutrients. And here is measured zinc, iron, protein, phytate, and there's less reduced levels of nutrients and protein under elevated CO2. So with nitrogen and protein decreasing on average by 13 or 14%. So this factor that there's a decrease in the nutrients and proteins in plants will have an effect not only on plants, but also on species at higher trophic levels and herbivores that maybe will have less diet, so they will eat more of the plants, and also will have a big significant effect on human nutrition. So our nutrition, maybe will have more yield, but it will have less quality yield. But this is the bad news. The good news is that in many cases, especially when you look about zinc, about iron, if you look at different cultivars of wheat and rice and field peas, you could find cultivars that can maintain a relatively higher nutrient content, less in the protein, but also in the protein. You could find cultivars that will have higher, mainly they're not commercialized now, but they could have higher protein. So there is a way to breed for crops that will have higher nutrients and proteins under elevated CO2. So to summarize, elevated CO2 in most species enhances growth and yield and decreases water use. These effects are nitrogen form dependent and are diminished under drought, warming, and nitrogen deficiency. Elevated CO2 lowers tissue concentration of nutrients, nitrogen, and protein, affecting food quality. The effects of elevated CO2 are not uniform. Some species and cultivars show less response. Elevated CO2 will have complex effect on growth and the composition of natural and agricultural plants. Thank you very much.
Okay, thank you very much, Shimon, for the presentation. There were two questions in the chat. So the first question was, plant acclimation to high carbon dioxide leads to decrease in photosynthesis. So will this not be mitigate the effect of high CO2 in the atmosphere? I think you answered this, but if you can clarify it again.
Yeah, so plant acclimation, what it does, yeah, there's with time, it will decrease, the 30% will go down to 12, and sometimes it will go less. So it will mitigate the photosynthesis, but it still has an effect on the nutrition. Okay, this is what I said, and they're still growing better, and there's more yield, even that. So maybe it's not going to photosynthesis, but it is going to yield.
Okay, second question. Do you think that we'll have changes in native plants pattern because of increase in carbon dioxide concentration? We're referring to C3, C4, and CAM species.
Yes, no, so it's also C3, C4, CAM, biodiversity, like I mentioned. Some plants will have less effect and some plants will have more effect, and therefore it will have a direct effect on competition and on composition, for sure. So this will change the biodiversity composition on Earth. That's why that was my last conclusion is in the talk, that will have complex effects on composition of natural and also agricultural plants. So the biodiversity also of agricultural crops will change, not only but also on the natural ecosystem. Yes.
Okay, question for me. Do you think that in the future we'll need to change how we put fertilizers in irrigation? We're doing fertigation today with nitrate and ammonium. And do you think the ratio should change in the future while increasing carbon dioxide?
I think this is the thing we have to keep in mind. Yeah, the ratio between nitrate and especially in C3 plants. But also this depends on the cultivars that will come, because cultivars will also have different uptake and effect. Yes, I think that the ratio of nitrate to ammonium is very important.
Okay. So thank you very much, Shimon. We will pass to Fulvio. Please share your presentation.
Thanks, Naftali. Let me try to share the screen. Can you see it?
Yeah.
Okay, let's go. Good afternoon. Nice to see all of you. I will be much more happy to see you in person. But anyway, thanks really for organizing and for inviting, and for sure we will have other occasion to do it. I try to keep this presentation rather light. I know this is a cultural event, not strictly a scientific seminar, and trying to leave some time also the picture to speak about our particular condition. The title is somehow provocative, because the question is if the cold climate can be good for the wine. We have a particular condition here on the Alps, in particular, but not only for Trentino. We are one area which is known in the world from the touristic point of view, the presence of the Dolomite and several other mountains. Dolomite are the most important because they are UNESCO heritage, but in general, as I think I will show and I believe I can demonstrate, the climate surrounding and occupying actually the major part of the landscape in Trentino have been for centuries a limiting factor also for cultivation. Nowadays, in the general context of global warming, there is one transition with a lot of cultivation of the grape, which is moving at higher altitude, and this is again a challenge, but is also an important opportunity. Here are some view just to see what we are speaking about. These are examples of some vineyard, mostly for the production of Chardonnay and some Pinot Noir in the four season. In general, most of the landscape of the viticultural area in Trentino, as always, is steppe. It is quite expensive to cultivate because the average surface of the vineyard is very small. There are thousands of small farmers, and in general, the horizon is like it is in the picture, with tall mountains in the background, and also the position and the orientation is important, because in most valleys it is possible only to cultivate if they are facing south, at least above the lowest altitude. Also, in general, the climate in winter is rigid. For example, this is a picture last week of Seraya Lake. This year we don't have snow because it was a particularly dry winter, but as you can see, 1,000 meters, even a big lake is covered by ice and people are skating. It means winter can be really cold. And in this context, the producers are considering to expand the production at higher altitude, like in respect of the recent past, in particular for the production of white and sparkling wines. What are the plus of moving in a cooler climate? The first is to reach optimal balance of sugar and natural acidity. Also in other important area for the production of sparkling wines in Italy, it is every year more difficult to preserve the natural acidity, and the harvest has been anticipated up to 40-45 days, falling in the middle of the summer when the nights are still very, very warm. This means that the excursion of the temperatures day in comparison with night is insufficient to promote the biosynthesis in the leaves and in the berry of the aroma and of the precursors, in particular for the production of the what is called Trento DOC, for example, in our case, which is basically produced with the same cultivar and the same technique like champagne, but the name champagne cannot be used because it is a trademark registered. But basically, one key point is to have one accumulation of aroma in particular precursor for the aroma in the grapes, and this is also very important. So for this, also the exposure to the sunlight is very important, not only the temperature. In general, moving towards a cooler climate, and I will show later why, all these parameters are improving. On the other hand, it's difficult to move in a cooler climate at the limit of the cultivation because, first of all, it is not required only that the average climate is suitable, but every day of the year must be suitable. So even a few exceptions during the year are enough to destroy the product. And indeed, the main problem here too are that the amount of temperature available is a limiting factor for the yield. And this means that it is unavoidable that going at higher altitude, the yield is decreasing a lot. It means you need to produce or with lower cost or a product at a high additional value. And another main problem is the spring frost, which is really the main problem. But this is nothing new. For example, also in the cool climate area of Australia, in Tasmania, is exactly the same. No? That, the area where there is late frost during the first few weeks of vegetation are not suitable for the production. And what is in general the forecast? There is a very nice work of our colleague here at Foundation Mac, Emanuele Echel and Roberto Zorer and others, which you can find, I believe, then the PDF. So if anyone is interested, not to look at the link, where they went to map and to do three different forecasts, of what it is expected for the production Trentino grape linked to the global warming. And as a matter of fact, the current area, which is the one in green, I don't know if I can see the, okay, maybe so it is more visible. So there are large areas of surface which are expected to become suitable for production. Another point is since the soil available in the region, cultivable, is very limited, also the prices are very, very expensive, among the most expensive in the world. This means that also expanding towards a new area now used to produce a cereal or a grassland or anyway production at much lower added value, it means that expansion in this area is also quite affordable in respect of the traditional area. And I'm going to do just two examples. The main is what is the most, the flagship of the wine for Trentino, which is Trento DOC. It is in Trentino is a region which has a bit more than 10,000 hectares of vineyard, and about 11% of this is for the production of Trento DOC. The varieties cultivated are Chardonnay, Pinot Noir, Pinot Blanc, and Pinot Meunier. There are this year 63 wineries, but they are increasing at the rate of 2, 3, 4 every year, because this product is much requested by the market, and I think also the production is increasing. In 2020, were sold about 10 million. This year, the last figure I saw were above 11 million. So in general, it is on the rise. And there are three product with 15 or 24 or 36 months of aging for the different level put on the market. But in reality, 50% of the product are aged 36 months or above, and the best product are released at 10 years of aging. We did a main experiment which was convincing and is still nowadays used and supporting of you the name of bubble mountains for this wine, because we did one experiment published in 2016. By the way, it was one experiment done in collaboration also with the friends from Ben Gurion of Negev, Aromatic, and at the time also David Tubiana was present there. What we found that there are a large number of markers which are influenced by the area of cultivation, and also we found that there are two kinds of products in the final wine which are reaching a higher concentration. There are several varietal aroma, in particular terpenes, and also a few pre-fermentative compounds which are certainly linked to the microclimate. And while other compounds are also important, are linked to the technology, in particular to the two fermentation needed to produce the sparkling wine. In this case, they are more higher in the sparkling wine produced in a nearby area, which is Franciacorta. I'm going to show you what is the aim of this study. We sampled the real wine on the market in 2013, and we included a final wine from the vintage for 6 different vintages from 2004 until 2009. To give an idea, Trento DOC is basically all the province of Trento, and as you can see on the left is completely covered by mountains. There is a main valley in the middle, which is the valley of Adige River, but the sparkling wine is only in a relatively small part cultivated in this valley, is more cultivated at the altitude and in some lateral valleys. And the comparison was with Franciacorta. Franciacorta is the other main area of production of sparkling wine with the traditional method. It is at more or less at the same latitude in the southern part of Lago di Iseo, so in just the west of our area. In this case, it is facing the plain called Pianura Padana, and so in general, the climate is warmer. We will see then later some figure about. Looking at the aroma in this sparkling wine, we sampled at the time at least one bottle for all the producer of Trento DOC, and we selected 11 of the main producer of Franciacorta, choosing on average wine having the same percentage of varieties. So we found in total almost 1,700 compounds using a comprehensive gas chromatography with a time of flight detector, which is a huge number. It is 10 times more than the compounds which are annotated and we are using, for example, for teacher courses of wine chemistry. Of these, more than 700 are different, only present in some product, and they are depending on the cultivar used, on the yeast, on the winemaking, and all the liquor which is added at the end, at the moment of the bottling, of closing the bottle, and also the use of barrels. But of this compound, almost 1,969 compounds are present in more than 2/3 of the wine. And basically, this is what is called the common aromatic matrix. And going to look still more on what is distinguishing the area, is commercial wine produced out of the same variety, using pretty much the same technology. I would say that even in several cases, the consultant enologist is the same person. They still have a subset of almost 200 compounds, which have a different concentration in the wine produced in the two areas. We went to basically to annotate manually all these compounds highlighted in red. And what means this? That if we are running one unsupervised classification, so one principal component analysis, not one discriminant analysis or some other analysis aimed to separate, but if you are doing a simple principal component analysis, as you can see on the first two axes, principal component 1 and 2, we can see that all the wine produced in the Franciacorta area are on the left, and all the wine produced in Trento are on the right side, without exception. Of course, we are in a way we are saying that the two compounds, the two wines are can be distinguished from the sensory point of view. Nor we are saying that one is better than the other, because in both cases we have in this in both selection young wine, aged wine, wines which are on the market at 15 euro, and wine which are on the market at 100 euro. So of course the quality, the age, and the several aspects are different. But obviously this means that there is a common matrix in the composition, which is independent from the style of the winemaking or from the choice of the winemaker, and we strongly believe that it is dependent by the microclimate. I'm showing just in general to avoid to bore you with all the compounds. Anyway, in the published work there are all the details. The main difference is in the terpenoids. The concentration in terpenoids on average in Trento DOC is approximately 2.5 times higher than in Franciacorta. We are speaking about neutral grape, what is classified classically as a neutral wine. But this conclusion is well coherent with the observation that for the biosynthesis of terpenes, you need to have a cold night and warm but not too hot day. And in Franciacorta, the harvest now is moving towards 15-20 of August due to the climate change, while in Trentino, the harvest starts normally around the 25 of August and lasts until the 20th of September. Moving of 3-4 weeks means that the chance to have several days where there is a very good excursion and the plant can accumulate this kind of compound is important. The second kind of compound which are changing are the pre-fermentative compound, the aroma with 6 atoms of carbon. Also in this case, we have about the double on average, of course, with exception in Trento DOC, and this is due to the different technique of the stemming, but also to the fact that in Trentino, having a cooler climate, we can wait until the optimal maturity is reached, while in the case of Franciacorta, we need to harvest a bit in advance when the natural acidity is still adequate for the production of a sparkling wine. And it is known that these compounds are produced much more when the grape has a higher maturity. And for the fermentative compound is the opposite, because since the grape has a lower content in primary aroma, the choice of the winemaker is towards using more the technology to obtaining secondary aroma produced during the fermentation. Having a general view, so I'm going to compare the kind of heliothermal index, trying to compare the temperature scale centered and fitted to a model to be displayed in the different and compared, you can see here that this heliothermic index is in general lower for the Trento dock. So the white dots of Trento dock are always below the black dots of Franciacorta. And another big difference is that in Franciacorta, the maximal altitude is about 400 meters, while in Trento dock, the traditional production is covering up to 700 meters above sea level. And now I'm going to show you some example of what is the direction, so what is happening now. And the first few slides are regarding where is going Trento dock. Looking at the importance of moving away from the bottom of the valleys and the warmest place, several producers are moving at higher altitude. One example, I will show you a few examples of what is doing the main, the biggest winery in the area, which is Ferrari. Is a very famous brand. Is also the one which we are using this year, for example, to toast in Formula One race. They are going to expand in this area, which is Sclemo, is the village. It's in the commune of Stenico. This is one map taken from Google Earth. As you can see, it is very close at the limit of the Dolomiti, the western part of Dolomiti, which are called Brenta Dolomite. This side is Cimatosa, is one mountain which is 3,050 meters tall. And of course, this is one area which has the influence of the tall mountains nearby, and it has never been in the past suitable for cultivation of grape. And here is what is going on now. This is a view, these are which I'm going to show are all pictures taken in 2021. This is the area which is in general considered. And these are 14 hectares which has been planted and are now in production, all for the production of Pinot Noir and Chardonnay, for the production of sparkling wine. This is another area, again in Sclemo, the way not far from the previous one, an area of 6 hectares which will be planted next spring. This is another area not far to that, again in the same valley, close to the Brenta Mountains. We can also see some mountain behind. And this is Tignerone. Again, this is one area of 16 hectares. This is how it looks in 2021. It has been planted, and now the new product from this winery, in this case is the farm of the family, no, the Tenute Lunelli. These are the products which are already produced in the last 2-3 years are coming largely from this kind of vineyards. The second and last example I want to do is that another frontier is that of the PV variety, so the interspecific hybrids, which are produced from interspecific hybrids, which have been now registered and are authorized for the production in Italy, and do not need to be sprayed against the fungi, against Plasmopara, for example. This picture is taken from the competition of PV wine, which has been held at Foundation Mac here in December 2021. So our products which are already largely present on the market, there are above 150 wineries in Italy, and there are about 30 producers in Italy. Again, I'm going to show just one example. Again, this is one area which is called Grumès. Grumès, going from Trento, there is the Cembra Valley from from where most of the picture I showed you before, no, at the beginning, at the opening of the speech, was considered the coldest area, Val di Sembra. And now, also at the end of Val di Sembra, there is the area of Grumes, which has been in production since the last 6-7 years. This is in line with Val di Fiemme and then Val di Fassa. So this is the area which is going directly in the core of the Dolomite. Moina and this is Pozza di Fassa. These are already the main area of the Dolomite. This is one example of one vineyard, relatively big, no, which has been recovered. This is how it was the area in Val di Sembra before. It was above the limit of cultivation of the grapes, considered traditionally. As you can see, it's very steep. There is a Visio River on the bottom, and this is on the right is how it looks now. Which is the wine which is produced in this case. It is called Zero Infinito. As you can see, the symbol. It is it is produced in this case with Solaris, which is one interspecific variety which is very resistant, but has a very short growing period. It is ripening very early. To give one example, here in the main valley, it will ripe still at the end of July or first week of August. So in one period where, so which is 20 days or 25 days before the winery are opening, and it's also producing a flat wine, but at the limit, it's producing a very aromatic wine. In this case, it is a kind of sparkling wine, which is sold as Zero Infinito, because the philosophy of the firm is not to spray, so not to use any kind of chemical spraying in the vineyard, and then with a technology not so simple, it is produced as sparkling wine without using any chemical also in the winery and without adding SO2. And again, this is a wine which is also in this case an example of success, because it is a production of about 25,000-30,000 bottles a year, which are sold within the first 4 or 5 months after they are put on the market. And in general, another aspect which is, I think, this is just one example. I could bring at least a dozen of similar cases, or the area of Trentino or Südtirol, but just to remember that with the resistant variety, we can also work a lot on the point of the impact on the environment, because when you are moving away from the traditional cultivated area and you are going in an area which are much more frail and uncontaminated, I think to go to use this sort of variety is helping a lot to have a lower impact, and also to reduce the cost, because of course if you don't need to go to spray 10, 12 times or 15 times during the year, it's also the cost, the CO2, and also in general, no, the value of the product is quite interesting. This is while Trento DOC is the flagship of Trentino and is recognized as a very important and successful product. In this case, the several different interspecific hybrids are still at the first year, and they need to be still known, and also to find in particular one link with the terroir, because it does not make so much sense to sell this wine with the name of the variety. In our case, in Trentino, again, these wines are interesting because they have been breeded mostly in Northern and Central Europe, for example, in Freiburg, also in Hungary, and in general in considering, and also they have been mostly produced and registered 20 to 30 years ago. So they were produced having in mind a different climate. So they are all wine which are difficult to be considered for a normal climate. While some of these are very resistant to the frost and can perform much better in one area which we are all considering impossible for the cultivation of the grape only 15 years ago. So this was all, and I'm happy to answer if there are questions.
Fulvio, thank you very, very much. From what I see, we are going higher with the vineyards, yes, because
Yes.
the snow is also is not coming, yes, or is not staying for a longer time like in the past. Yes, we can also see it in the exhibition in Sde Boker campus with 140 pictures that were captured 130 years ago and last year. You can see you can distinguish the difference in those years. So it gives us some opportunities. That's what you say, that suddenly it's exposed soil that could not be cultivated before. Do you think it will be sustainable? What if the snow will come back to those places?
Of course, this is the main issue because the permanent glacier have been in several cases disappeared or are going to disappear from now in 2050. And they are the main reservoir of water. And there is still a good amount of water in this area. I think if between the people attending to the meeting, for example, there is my colleague Emanuele Echel, which has published several work on that. I mean, there are seasons, for example, autumn, where we have a relatively higher frequency of rain, but the lack of rain during the winter and the disappearance of the glacier is for sure an issue also at higher altitude. So the water, I was mentioning the yield and the frost, but the water availability will be one issue, but not particularly in my view for grapes here on the Alps, because as we learn also from the experience in the Negev desert, I mean, grape is very resistant in terms of availability of water. I think it's not among the first plant which is going to suffer.
So Fulvio, are you using different rootstocks in the mountains, or using the same one, or different methods of trellising, or something is different, or just going higher and higher with the same methods?
No, basically the choice of the rootstock is pretty much the same. There is some change, but also because I've been released during the last years, for example, from the University of Milan, some new interesting rootstock, because before we had 1 century without any new release. And now there is something novelty, but not because the old one are not performing there.
Okay, thank you very, very much for your talk. The next speaker is Professor Aaron Veit. Aaron, can you share your presentation, please?
Yep. Do you hear me, first of all? Do you hear me?
Yes, loud and clear.
Great. Okay. Now I'm trying to see. I have here a privacy thing for some reason that I cannot access. Okay, quit. Okay, let's see if I can share it. It tells me. Is there any password related to this, or is just my Macintosh?
Share content. Control-Shift-D.
Yeah, no. This, but the Cisco WebEx meeting tells me that I need to for some reason, grant access in system preferences.
Okay, can you send me the link and I will share it? Maybe it will be faster.
Let me try this again. Okay. Quit and reopen. Okay. Now, Naftali, let's, I quit and reopen because this is what it tells me. Okay.
Okay.
Good.
I will entertain everybody.
Oh, again, same. Unbelievable.
Okay, Aaron, can you send me a link to the presentation?
I have no idea why it wants to grant access to, I don't know. Okay, I'll share it with you. Yeah, I'll share with you. Let me get to that. Okay.
Sorry, but it will take 1 minute and it will be done.
Macintosh things. So, okay, I send it to you. Let me know if you got it.
It's Lab Companies PPTX, this one?
Yeah. Well, in the meantime, I'll present myself. So our laboratory, in the laboratory that I'm working and that I'm managing, and that the students are giving so much of their time, is mainly a plant biochemist laboratory, where we use metabolomics platform, a metabolomics tool to study fruit developmental processes and plant response at the molecular level. We have several projects running in the lab, from the response to salinity of tomato and the response to salinity of grapevine, and more dedicated projects that look into specific biochemical pathways, like, for instance, the resveratrol pathway, which is an anti-inflammatory, and that we try to enhance its production mainly in vitro, in cell culture, that do remember they come from berries or berry skin, to be specific. And they produce this anti-inflammatory compound at very high levels as compared to the regular fruits. These compounds are responsive to a plethora of stresses, but in humans, it was linked, especially resveratrol, but not only, the whole stilbene family, to antioxidation process or and anti-inflammatory processes. So they could be really of potential use in the nutraceuticals. Naftali, did you manage?
Not yet. It will take me 20 seconds.
Okay, so I'll continue. In respect to field experiments, we have been working for the past 10 years on grapevine at different levels and with companies, and also just basic science. You can go to slide number 3. Right. And so as you can see, we have both greenhouse experiments, we have field experiments. We used to work with companies, large and small companies from Carmel, Tepperberg, Nana, and others. And we address different topics in the Grapevine environment system, from the canopy response down to the cluster and to the rootstocks. And you could recognize in the digging in the roots, you could recognize the chair of this session, Naftali, digging out there. Next slide, please. All right, so why grapevine? Basically because grapevine is a very valuable crop. It's quite resistant and tolerant to conditions that could be challenging for other crops. And that in the desert, or in the Negev desert, the mountainous part of the Negev desert, we had wine production for thousands of years, or thousands of years ago, because there was definitely a break of hundreds of years before it started again at the end of the past, at the beginning of the past century. So the next slide. In general, worldwide production and Israel production is a kind of a plateau. The worldwide production is increasing, in Israel is decreasing, but if you look at the area harvested, worldwide is decreasing. This is due mainly to technological improvement. What is kind of worrying is the Israeli side, where there's harvested area kept constant, but the production is decreasing. And production is actually decreasing also in France, I've been acknowledged, which was kind of linked to climate change issues. And what we know is that, for instance, in the Negev desert, we have varieties like Cabernet Sauvignon that are also decreasing in production in the past years, which could be also linked to unusual weather, especially in the winter, in the Israeli Negev in the past years. Next slide. Overall, from modeling studies, it was kind of predicted that if we had an increase of 2 degrees worldwide, we could lose from 20 to 60% of the current wine growing regions, which is really a huge amount. And these are already expected increases in global weather. So the idea of a slight increase in air temperature or a slight global warming with a great loss is really worrying the viticulture and wine industry. And this is why, and you can go to the next slide, we started to have works on genotypes and environmental interaction. Next slide. One of the most common issue in desert Negev or in desert areas is the effect of temperature or radiation on the crop production and crop quality. In this slide, you could see easily that heat waves, for instance, could cause a flower abscission, and eventually, during maturation of the fruit, we could have changes in the berry metabolism and even shriveling of berries. Next slide. Next slide. To try to understand what are the reasons, if the reasons are more genetics or more environmental, what we did was to use an extensive collection that was set up by the guys at the R&D in Ramat Negev, including Amnon Bustan and Eran Arkabi. And that these collections are grown in 2 different sites. And you could see them in the left hand map. They distant about 50 kilometers. But more interesting is that the change in temperature between the 2 sides is about 2 degrees and quite consistently across the seasons. And the varieties that we've been working on are 30 varieties. 10 of them are white varieties and 20 are red varieties. They are grown on the same rootstock. They are in the same kind of shape in respect to plant architecture. So overall, the climate is, the irrigation system is the same, the climate is the same beside this temperature shift. Next slide. Okay, next. So this is just to show you how much the temperature was consistently higher in the Ramat Negev area. You see that in the bar graphs, for instance, the distribution of the temperature, and you see that we are about 1.5 to 2 degrees difference as for what concerns the Ramat Negev temperature as compared to Mitzpe Ramon. Next slide. So basically, Ramat Negev is a kind of what would be the climate in 50 years from now when global climate is 2 degrees warmer. Okay, so Ramat Negev is that scenario. And we have 30 varieties growing there and 30 in the cooler Mitzpe Ramon. And what we did was to analyze, first of all, the phenology of all the 30 varieties in these 2 different temperature climate. And later we did harvest them as well at the horizon, and we harvest them at harvest. And we measured berry indices, carotenoid and polyphenol compounds. Next slide. Next slide. So overall, what we could find was that for mainly white cultivars were earlier and had earlier and shorter ripening phase, which made them avoid the summer heat. And this is actually something that was kind of, I wouldn't say expected, but we didn't think that it was indeed an advantage. And in fact, if you look at the history of the Mitzpe Ramon and Ramat Negev wine production, it actually started with red varieties, kind of considered more tolerant to the conditions in the Negev, or maybe easier to manage. But our study and also the farmers that we talked to realized in the recent years, in the past 2, 3, 4 years, that actually white varieties do have a great potential in the desert area. And also, especially in that area that becomes 2 degrees warmer during the summer, because already the white varieties are being harvested early in the summer, so they are not exposed so constantly to these 2 months of very hot and warm conditions like most of the red varieties. So white varieties, you can see here, mature earlier. They have a shorter ripening phase. They had lower oxidative stress in their grapes, lower degradation also of carotenoids, but this was kind of changed among varieties. So that overall, the fruit quality of the white grapes was kind of better than the overall quality or degradation grade of the red varieties. Among the red varieties, actually, we had some that even did not reach the correct parameters or berry indices for harvest. And this led to the cluster collapsing. So our study also indeed indicate what are those varieties that should not be grown at a temperature warm like the conditions in Ramat Negev. This one of the obvious variety that had this issue was Tempranillo, but was not the only one. Tempranillo simply had a very, very clear phenotype, which was the collapsing and shriveling of the fruits close to the harvest. So as you see, to conclude this part here, both radiation and temperature seem to synergistically affect carotenoid and phenylpropanoid degradation, but the varietal component was very clear. So this is the other conclusion of our study, that the grapevine biodiversity, in our opinion, bears the key to the challenges, the future challenges in a changing climate, okay, in a future changed climate. We do have enough biodiversity here to support, to face a climate change. And actually, discussing with Fulvio Motivi, which I met physically last week, and was so much to meet a great scientist and a friend again. We were talking about these issues, and he also reminded me that there are certain varieties, for instance, in Sicily, that they mature in October. Okay, so basically they are not early maturing like the white varieties, but they actually escape kind of the summertime by really this slow maturation and being harvested in mid-October. And this is in Sicily, which is a climate, I wouldn't say close to Ramat Negev, but definitely a climate quite similar to the central areas of Israel, central south area of Israel. Next slide. Another issue which is related to radiation is obviously, which is related to temperature, is obviously radiation. So all of these studies actually couldn't really separate radiation and temperature 100%. Although the study that I'm going to show, its highlights, did actually aim to that, and in partly it achieved that. So and this study was very relevant for the companies that we are also working with, like Carmel and Teppelberg, and actually was a very tight collaboration with Teppelberg wineries. So radiation can have a drastic effect on berry quality. It can induce oxidative stresses, and these oxidative reactive oxygen species actually can really damage not only membranes and even the DNA, but they can have a rather great effect on the chemistry of the berries, and eventually, obviously, also on the chemistry of the wine. So companies in the which are growing in the Mitzpe-Ramon area came to us and said that they were greatly suffering from shriveling and from, especially in white varieties, they were actually suffering from the browning of the skin, which is an evidence for the degradation of compounds and for oxidative stress. Go ahead. So we set up basically here you see basically two experiments that were performed in a few years. One was on Cabernet Sauvignon, the other one was on Gewürztraminer. The one on Cabernet is on the left-hand side, and was using nets. And the one on the right-hand side, which compared a VSP, a vertical shape of the plant against an open canopy, was used in Gewürztraminer. So the differences are obvious of these two types of management. Now, I must say that by talking with farmers that did introduce the opening of the canopy, they are kind of satisfied because they achieved a better shading of the crop, improved quality. The clusters got also a little bit more loose, so avoiding even biotic stresses like potential fungi. But at the same time, an open canopy transpires more, so loses more water to the atmosphere. And this means that we need to add water, and water in Israel is fairly expensive. In the meantime, water being used in the vines is definitely fresh water, mostly fresh water. And so that the other possibility by netting the cluster area would be a more cheaper, at least in respect to water resources. At the same time, clustering this clustering shade demands a little bit more attention, especially if you need to move into the field and spray, for instance, against fungi. Okay, what is a positive an advantage in desert areas is that you do not spray that much. Actually, I think that a few of the farmers do not spray at all against fungi in that area. So the netting system is also gaining more attraction by some of the farmers we were talking about, and we are going possibly to implement it as well. But these are the two experimental designs that we assembled for studying the effect of radiation on the berries. Next slide. So this is just a slide to show you how the effect of the cluster zone temperature, how we kept the cluster zone temperature rather similar. And this is shown by the overlapping of the different lines. What should be also the humidity. You can see that the lines of the humidity are basically overlapping, so the net is not really inducing an accumulation of humidity, which could lead potentially to more fungal issues, or molds. So that was kind of a good thing. Next slide. What should be seen here in these figures here, which are from the neutral gray shading net, is the fact that we basically create a more homogeneous environment. So if you looked at the same thermal camera image for the exposed berries, you would see on the exposed site, you would see a very bright red color, like in the background that you see in this picture here, which basically means in those thermal photographs, it means about 45 to 50 degrees berry surface temperature. This means that an exposed berry on a VSP shape is feeling 45 to 50 degrees temperature daily for 2 months, if it is a red berry, okay, of about 2 months. And this is obviously way too much. Also for white berries, 1 month is way too much, and this is what possibly causes the browning of the fruits, the oxidative, the oxidation of volatile components and volatile precursors, and the feeling in your mouth when you drink an oxidized wine, which tastes a bit like an strudel, an apple pie. Okay, and that's not good at all. But you see that as long as we use this gray shading, we reduce significantly the overall temperature of the cluster, and we bring it back to very decent degrees, like 24, 25 degrees overall, and definitely a very much homogeneous fruit on the exposed part and more on the internal part. Next slide. Okay, let's go on to the next slide. So overall, the effect, you might hear my daughter screaming, please ignore. So on the practical side, what were the results of the netting system? Well, first of all, you see in the bar graphs in the upper left side, you see exposed the orange bars. And you see that between the date before harvest and the harvest date, which is more solid orange, we basically lost 24% of the berry weight, okay? Which is a huge amount if you think about it, right? Now, as soon as we use the shading nets, especially those in the gray areas, the 30% shading, or 60% shading, you see that this loss in produce is much more contained, right? We are between the 8 and the 5% loss in product, which is amazing. I mean, is definitely much more limited loss in crop yield. At the same time, we can see in the pH, for instance, that we could keep with the two gray nets, we could keep the pH rather lower towards the 3.7 as compared to the almost 4, yes, of the exposed berries. Now, pH is an important characteristic of berry quality, and which higher pH is associated with usually with a lower quality of the wine. And nevertheless, you see that the berry Brix levels were not as much affected. You see that the exposed berries in the left bottom corner, the exposed berries were above 24 for Brix at harvest. The gray shaded 30% was 23, and the gray shaded 60% was 23.5, I would say. Again, not much an effect on the sugar, which was rather kind of not as expected. I would have expected more significant effect. So it means that basically the Brix level depends not only on berry surface radiation or radiation slash temperature effect. Next slide. Next slide. I will conclude with these 2 slides more. Another very important area that we are entering and that we've been working already for a couple of years is the production of health promoters by desert-grown crops. You know, the grape skin is a treasure, in the sense that it it synthesizes and accumulates a large amount of secondary metabolites or specialized metabolites, like let's call them like that, including the polyphenolic compounds, which have a lot of interesting properties like antimicrobial, anti-cancer, anti-diabetes, antioxidant, anti-inflammatory. So overall, obviously, we are talking here about metabolites that could have a potential use in the nutraceutical industry, if not in the pharmaceutical industry. And they are being already used for several nutrition adjunction for a healthier organism. Now, in the desert is the best place where to produce specialized metabolites, because usually these metabolites respond to stress and they are being induced by stress. So we have now, beside the biodiversity of the collection that we are exploring, and we are basically rating the different varieties according also to their production of antioxidant and anti-inflammatory compounds. We have also in vitro studies using cell cultures derived from, for instance, the skin, which I anticipated earlier. So these studies show that either by cues, so chemical cues like hormonal cues or environmental cues like increasing the cell culture temperature or radiation, we can induce the production in vitro of these secondary metabolites. At the same time, what we can show is that using a transgenic approach by tackling the enzyme that lead to the production of these very specific secondary metabolites, we can increase the amount by hundreds-fold. And so this is published already by myself with Michal Oren-Shamir of the Vulcani Institute, and is being also patented as an anti-inflammatory method in the context of the COVID attempts to mitigate the inflammatory effects of this pandemic. Okay, so go to the last slide, I guess, and we can close that, because I took a lot of time. So that's the lab actually in its previous form. 2 months ago, we got new entries, and we had people leaving. One of the major students that you could see here is Kelem, which is above my head. You see with his wife, Kelem Gashu. Yes, right, perfect. Now he's in the United States for a postdoc. Then I have to thank here definitely Noga at the very leftmost of the picture, Tanya just below Noga, and Chao because he helped a lot of time dealing with the data analysis. He helped Kellen for that. So, and thank you all for listening.
Okay, thank you very much, Aaron. Okay, I don't see any question in the chat. I will ask you 2 questions. Do you think that in the future we will have wine that was produced solely from tissue culture, that everything will be inside some containers or something like this? That none of it will be from the field?
I don't want to imagine Fulvio's face while you are saying that. Look, eventually, the field is an enormous, fundamental resource for a good wine. Okay, so I don't know what kind of future will lead to in vitro production of wine. What is nice about the in vitro cell culture is that there we can take secondary metabolites, or we can extract the cells without the issue of sugars and alcohol. Okay, so if you take a pill of this dried extract, it's like you, in terms of polyphenol content, it's like you are drinking a couple of bottles of wine without the alcoholic effect. Okay, but this is, you know, this is a more a health issue. It's definitely not an issue related to wine quality. So I tend to respond that day I prefer to be among the stars and not being still alive.
But do you see any combination that can happen between the berries that coming from the field and whatever something that is coming from the lab?
Look, again, I don't know whether it can be, it will be combined, or for any reason, maybe to enrich, okay, a must with polyphenols or with stilbens. Okay, maybe you could possibly think of like you are doing blends today. Okay, you take your Cabernet Sauvignon, but since it grew in northern parts of Italy and has maybe sometimes low amount of polyphenols, then you enrich it. But this I don't know how it will be sold on the market and how it will pass the regulation, if it can be called still a Cabernet Sauvignon with any denomination of origin, but this is a possible outcome.
Okay, thank you. Fulvio, your face looks pretty fine when I mentioned it, yes?
Yeah, but I was thinking it was a joke.
Yeah, but from every joke there is some something real, yes?
Of course. But
yeah, I don't know. One day we want to create wine on the moon or somewhere else on Mars or something, and then maybe we need to do it in the lab.
We had a very participated discussion in a recent event on the resistant varieties, no? And for example, in that case, there are several really excellent wine. But a general opinion of wine critics is that until we will be able to demonstrate that cultivar or grape is giving that specific result because it is interacting perfectly with the terroir, then it will have a real value. Because we are speaking of a product which is produced in such a large amount and almost everywhere in the world nowadays, in all the continent, that people need to have also a story behind. And also the most successful area are those where you can recognize and have a unique balance due to the area. Therefore, for example, I find very interesting the last result which Aaron showed about and surprising about the performance of the white varieties, because, for example, nowadays we don't have one region characterized by the production of a white variety from a warm area. If there would be one possibility to find a unique style on that, could be something unique and of value.
Yeah, Fulvio, I already invited you to taste the Chenin Blanc from Mitzpe Ramon area, which is an amazing wine. So I invite, by the way, all of the audience to get to know the desert wines.
Keep a bottle, sooner or later I will come.
Okay, thank you all for the interesting presentations. I must say that I enjoyed the presentations, and I could see that all of us have challenges, and the future probably will have more challenges, but those challenges can be opportunities for different terroirs, different qualities. Yes, and with the nice and good research that we are having in our institutes, we will have it. Yes, we will always drink good wine, I hope. Okay, thank you very much.
Thanks, Naftali, and thanks to all.
Thank you all. Bye-bye.
Bye.
Bye-bye.